Welcome to the FarmBits podcast.
FarmBits is proudly produced by the Nebraska Digital Agriculture Team and hosted by students at the University of Nebraska.
The FarmBits podcast comes to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews with experts, producers, and innovators from across the agricultural industry, we hope that you step away from each episode with new practical knowledge of digital agriculture technology.
Hello, and welcome to the 50th episode of the FarmBits podcast. In this episode, we are joined by Dr. Tami Brown-Brandl, professor and researcher in the Department of Biological Systems Engineering here at the University of Nebraska-Lincoln. Dr. Brown-Brandl has degrees in math, chemistry, biology, biological systems engineering, animal science, and agricultural and biosystems engineering.
Dr. Brown-Brandl has a research program that is focused on engineering approaches to improve animal well-being and production efficiency by incorporating areas such as calorimetry and animal energetics, development of sensors and control systems, and precision animal management.
Hi, Tami. Thank you for being here with us today. So how did you get interested in precision animal management, and what is your why?
So I've been doing research for over 20 years. And when I got my PhD, I really focused on environmental physiology, right? And so, but my mission statement always has been to develop management tools for livestock producers to help them make critical decisions. That's always been my mission statement. So although I wasn't ever working in precision animal management until the last about 15 years, I've always had the mission statement of developing tools. So I guess I just think it's the natural progression of where we need to be with livestock farming these days, or livestock production, is to use the resources available to other industries to our benefit, to help the animals and help producers maintain those animals.
Absolutely. What is your favorite part of your work? It sounds like you've spent a lot of time working towards improving the lives of animals. Is that?
Yeah. So the favorite part of my work, I have a quote in my office, and it's "Do what you love and love what you do." And I really wholeheartedly believe that. So my favorite part of my job is everything. I love working with students. I love helping students find their passion. I have a passion for animals, and I also have a passion to help producers take care of those animals. I think producers really care for their animals. They're just very, very busy people. And so I think precision animal management is critical in helping those producers do the best that they can in their situation, right? So I guess there isn't a part of my job that I don't like. So.
Right, definitely understandable. And I love that quote. You always tell us, well, the students in your lab, that quote, and I really love to live by that. So what approaches do you use to tackle a problem or research question?
So let's just start out, like, we just started a new poultry project this year, right? And so when we started looking for broiler breeders and applying technology to the broiler breeder area, so what you have to do is you have to understand what the producers are doing now. And then you start looking at those critical decisions that they need to make. And when they make those critical decisions, what are they basing that on? And so being able to take what the producers are seeing with their eyes and their ears, and figuring out, is there a better way we can do that? Is there a way we can monitor those same things, or sort of substitutes for those same things, on a second by second basis or a minute by minute basis. So we can start gathering the same information the producer would when they walk into the barn, but we're doing that 24/7, 365 days a year to help that make those decisions later.
And that's through the use of some of the precision technology.
Yeah. And so, yeah, you're right. So then once we figure out what we want to monitor, then we start figuring out what the best way to monitor it is. So we might use cameras, and image processing or deep learning or machine learning, or we might use RFID, or we might use a wearable. But you kind of have to look at the animal, and you have to look at the situation, and you have to think, how easy is it going to be for us to, first of all, collect this data for the research project, but then longer term, how easy is it going to be able to switch that to the producer? And like a wearable on a broiler chicken, on a broiler breeder, may be reasonable. On a broiler chicken is definitely not reasonable, right? You can't put a wearable on a 50-gram chick and expect it to be on that 50-gram chick 6 weeks later that now weighs, I don't know, 4 pounds or 3 kilos or whatever. But also looking at image processing. And if you're looking at a sow on a farm, is it reasonable to do all this image processing, or to put cameras throughout a barn? How reasonable is that? Is it reasonable to maintain those? So those are all the sort of questions we ask when we start getting started on a project. And we might do stuff in research that could not be easily applied in industry, but might give us more information about what the subject we are studying. So that's kind of where we are.
Nice. So, Tami, you have a group of graduate students and student employees that work through research and innovation to enhance the way farming is done in your animal management innovation lab. What is some of the work that your group of students are doing?
So I have I have students, and we're doing a lot of really, really fun stuff. So we are working in basically two species. We're working in swine and poultry right now. I'm playing around with getting some dairy and some beef going. I don't really care what species I work in. And in the swine, when you start looking at precision animal management, you have to start subdividing it to what production stage you're going into. So we're doing some grow finish swine, and we're doing some stuff in sows. If I just pick on what we're doing in sows, we're really looking at trying to take those animals from a gestation stall and put them in a large pen. And when we do that, what pieces of information do we need? So we're looking at lameness detection. We're looking at condition score. We're looking at, when we get over to farrowing, we're trying to gather some information. We're trying to assess different types of farrowing stalls. So that's more on the engineering side. We're also trying to develop some novel phenotypes on mothering ability. So that's more on the genetic side. I am far from a geneticist. I just want to let everybody know that. But it's important to work across disciplines. And so I can get some novel phenotypes and work with a geneticist and hopefully make some really great strides on the genetic side. And then on the same side, on the other side, we can start using the same data to start looking at which farrowing crate works best for lowering pre-weaning mortality. So we sort of subdivide everything. I'm not sure how much more research stuff you want me to talk about, because I could talk for a while, but I'm not sure you want me to talk for a while. So.
Oh no, that was awesome. It's really interesting to start considering the interaction of genetics and environment, nature versus nurture, and how all of that actually plays out in production settings. And then looking for those novel phenotypes, like you mentioned, and being able to kind of leverage that to improve welfare and well-being of those animals. That's really exciting. And I know Asia actually has some research going on in your lab right now. So I wondered if the two of you would like to talk about that a little bit.
I can tell Micah. I don't think we've ever really gotten into detail.
No,
about
we
my
haven't. Why
project.
don't you share with me a little
Okay,
bit?
so in my project, we're using wearable accelerometer 3D sensors. The accelerometers measure the acceleration of gravity in 3 axes, so X, Y, and Z. And those are the 3 acceleration axes. So what we are doing is, we place the accelerometer in a denim enclosure, and we paste it on the back between the shoulders of the sows with tag cement. And so with these sensors, we're going to use the 3 acceleration values to determine whether the sow is lying, standing, and then the 2 lying positions are lying right and lying left, and also sitting. And so we're using those postures for our static postures. And then we're going to get into dynamic, which is transitional posture. So if she's going from lying to sitting, or sitting to standing, or if she goes from lying to standing. And we're in the process right now of analyzing those values. So we're in the process of determining which X, Y, and Z value mimics or shows us what the sow is doing.
Very cool.
Very good.
Dr. Brown-Brandl, if you would share a little bit about how that story is playing into improvements that are possible.
So that's part of our sow crate evaluation and mothering ability study. So how we are doing most of that study is with image processing, right? So we have a digital and depth camera above each of the sows, and a digital camera gives you a digital picture, exactly what you get from your camera, right? Or from your phone. And what that is an array. An array is a series of columns and numbers, or columns and rows of numbers. And the digital picture, you get 3 arrays. You get an intensity of blue, red, and green, right? And when you merge all those together, you get a color picture. A depth image is a little different. A depth image gives you the distance from the camera to every single pixel in the whole image. And so you get this whole surface. And we've taken a lot of digital and depth images of sows above crates, and we can tell a lot of information about the sow standing, sitting, lying. The problem with those digital and depth cameras is there's a lot of hardware. I have a camera above every sow, so I have 60 cameras, and I have 60 computers, and I have a wad of Ethernet cables that's about 4 inches around that goes into a series of waterproof aluminum, 24 by 24 by 48 cabinets out in the hallway that gather all of that information. And so we can bring it back to Lincoln and analyze it. So while all that is fantastic, that isn't really replicable. If we wanted to take that to a farm is not going to want to put up all those cameras and deal with all of those little computers and all of that stuff. So our thought was, can we get all that density of data that we're getting with the images? Can we get some idea of that same information using an accelerometer or a wearable sensor? And so we're taking that's a long story, but you're taking that data that's very, very high quality, high resolution data down to something that may be applicable to a producer. And bottom line, we're taking an accelerometer that is, I don't know, what is it? About 2 inches by 2.5 inches by about a 1/2 inch. And that includes a battery, and that goes on the back of the sow, and we put it on a denim pouch. To really take that to industry, we need to put that in an ear tag. But when you go to put it in an ear tag, so an accelerometer measures all the accelerations of gravity. Your phone has an accelerometer in it. That's how it knows when you change the position of it. And so, yes, it knows static postures, right? So, or we're assuming we can tell static postures by the acceleration of gravity and where that acceleration of gravity is. So if it's like this, your acceleration of gravity goes in this direction. If it's like this, it goes in this direction. If it's like this, it goes through the center. So you get the X, Y, and Z components. But also when an animal starts to move, you get accelerations beyond just acceleration of gravity. So that's those dynamic postures Asya was talking about, right? You get these hopefully faster than or more than the acceleration of gravity. And then we can tell if the pig is actively moving or is just standing or sitting or lying. So anyway, we will turn that into that mothering ability phenotype is long-term what we're planning on doing with that.
Sure. Is that mothering phenotype associated with more movement or less movement? If you could describe that a little more.
So that's interesting. Right now, that is the question.
Okay.
And early results are that it really so mothering ability or the ones that tend, so we're looking at overlays, right? The number of overlays or deaths that occur from a sow laying on a piglet increases if the sow doesn't have very long kneeling postures. And a kneeling posture is when they go from standing and they go head down and then they kind of roll their back down. So they're going from standing to laying. And the ones that have a high number of piglets and low number of overlays had a significant kneeling event every day. So when they go from standing to lying, they're being very cautious and they're going head down and they're waiting for the piglets to move and then slowly laying down. The ones that are high number of overlays, those pigs don't have hardly any kneeling postures. That could be a genetic effect that on behavior, that could be simply a muscle, like how fit the pig is, right? Can they slow their rate of descent down? Or it could be a genetic thing on how much the pig moves around, which then in turn impacts the fitness of the pig, right? So there could be a couple things at play, not necessarily just the animal's ability to care for those piglets or the animal's want to care for those animals. There could be some physical limitations to that.
I see. Thank you for clarifying that.
Thank you, Tami. So what are the goals of your research program?
So yeah, I told you my mission statement, and I guess my goals go pretty close to that. So my mission statement again is developing tools to assist livestock producers in caring for animals with respect to health and well-being of the animals. So my goals in that are to, develop technologies that don't provide data to the producers. You can install technology in the barn and it'll give you data, but that isn't the end goal. The end goal is really to take that data and turn it into information. Because remember, producers are busy people. And while we love data, producers don't have time for data. Producers just want answers. And it can be a simple answer as in check pig A, or pig B is close to market weight. But you can't just give them a whole list of weights or a whole list of images and expect them to sort through all of that and find out what's informational about that.
Absolutely. Thank you for that. I see here that you have recently received some more funding for your project. So I was wondering if you could share a little about what your upcoming work or some of those new projects might look like in your lab.
Oh, I get really excited when we start talking about new things. So I'll tell you the really exciting project. So I have two exciting projects. First of all, moving and doing stuff in the feedlot or in the feed yard is a very difficult, or the feedlot is a very difficult area to apply technology to. I've done a lot of heat stress work and I've done a lot of work in cattle, but I have not applied too many technology things to cattle. I did build a RFID feeder system for feedlot cattle. The difficulty with feedlots is you have no electricity most of the time at a feedlot, and you have to have a place to run your wires, and there is no place to hang wires and to run instrumentation. So that's really tricky. So that's a really fun challenge to undertake, is figuring out how we're going to put things in the feedlot and how we're going to. And so some of the stuff we're looking at is, adding robots to the feedlot. Can we feed animals? Can we clean the pens using robots? So those are some of the questions. And then, applying some of the stuff we've learned in swine over to feedlot. But the really exciting project that I'm really working on is we just started a plan, and it's not really a grant, but we're just starting the planning for, it's called Dairy Innovation Center for Engagement. But really the concept is to reintroduce the general public to animal ag through a dairy in a dairy center. And why I think dairy is easy to introduce people to animal ag is dairy cows are very docile animals. They're large, but they're very docile. They're usually used to working around people, so they move pretty slow, and they would be good for if you had a group of students come through, that they could easily, pet the cows, and that wouldn't be a problem. Dairy calves I'm not sure there's not much cuter thing than a dairy calf, right? Pigs are pretty cute, Asia, but a dairy calf is also pretty cute.
Yes, they are.
The end product of dairy is a soft introduction to animal ag, right? Who doesn't love cheese and ice cream? So come and look at the dairy cows, have coffee and ice cream, and hear about animal ag. And so I think all of those things playing together with the already established technology for dairy is, the technology available for dairy is astronomically cool. We have robots that are milking cows. Cows are deciding when they need to be milked. They aren't milked at 4 a.m. and at noon and at 5 p.m. at night. They milk themselves. They go and the robot milks themselves. That engages engineering students and kids in STEM that have never considered being in ag. Think about a robot that measures how much feed is left on the ground, determines if the cows need to be fed, mixes up the diet, goes back and feeds that pen of cows. think about wearables on a cow that can tell whether the cow is lame or needs to be bred or is ready to give birth. I mean, those kinds of things are really cool and engaging for people inside and outside of ag.
Yes, I love that. I love the incorporation of the public and your desire to just wanting everyone outside of ag to, learn more about it. I think that's really interesting. So, do you think that precision animal management techniques could be applicable in veterinary medicine?
Yes, and they already are, actually. If you go to Europe, there is a company called SoundTalks. It was developed by an agricultural engineer by the name of Daniel Berkmans, and Dirk Berkmans, his son, runs the company. And what they do is they put microphones that are waterproof in a finishing facility. And it's really awesome because they record the sound in the building, and then they have algorithms that can select the coughs of individual pigs. And if you've ever been inside of a pig barn, you know how loud and how noisy it is. And for them to be able to filter everything else out and look at the coughs, and not only just look at coughs, but then they can tell the difference between a dust-induced cough and a pneumonia-induced cough. And so if they start hearing a pneumonia-induced cough, then the producer can set it up where they are contacted or their veterinarian is contacted. So that has a huge role in directly contacting and notifying veterinarians. Think about lameness in sows, being able to diagnose those animals, or maybe not diagnose, but at least identify those animals, which animals need to be looked at by a veterinarian. And I'm going to go one step farther, and I'm going to say our technology will not be able to diagnose, but they'll be able to identify animals that need to be cared for. And so that becomes a very critical point. So instead of hiring a veterinarian to walk through your building every day, which is really expensive and maybe not even reasonable, you're now hiring a veterinarian to look at the animals that have been pre-selected.
I would like to talk a little bit about that app that you helped develop to identify heat stress in feedlot cattle.
Sure. Okay. What information do you want me to tell you? What it is, what it does, or how it was developed?
Let's talk a little bit about what it is, and then what kind of opportunities or the resource that it is providing for producers.
Okay, sounds good. Okay, so Dr. Roger Eigenberg and myself worked together with the National Weather Service to develop a heat stress app for feedlot cattle. And so what it is, and it's free for anybody to download, and it's on the App Store and it's on Google Play. And it is called Heat Stress. And I think you'll have to look for Heat Stress feedlot cattle or something, because there's quite a few heat stress apps now. We developed a website first, and that website, I don't know how old it is. It might be 12 or 15 years old, and the app is probably maybe 7 years old. And so what we do is we look at 4 variables. We look at temperature, humidity, wind speed, and a surrogate for solar radiation, which is cloud cover, which isn't the best, but it's okay. So we look at those 4 parameters, and we do predictions 7 days in advance. So of course the predictions for today are probably pretty accurate, but may not be perfect, but are normally pretty close than the ones 7 days out. The farther out you get, the less accurate it is, just based on weather forecast data. And what that, then it goes in and it calculates it calculates an estimated respiration rate, and it divides it into 4 different color categories. And so you have a map of the whole continental United States, and you can zoom into any part of that map and see what heat stress level you are. You can also drop a pin at certain locations, and then you can say, please give me heat events 3 days out, 5 days out, 7 days out. And so then it will push notifications to the front of your screen if you need to take action that afternoon. It also has a section in there for producers to understand what heat stress looks like, so they know which animals are more at risk during a heat event and which ones are probably doing okay. And then it also gives you information on what steps you should take to alleviate heat stress. And it'll break down stuff that you can do ahead of an event or during an event. And some of those we took recommendations from people all over the world that were working in heat stress, cattle heat stress. So a lot of our recommendations came out of Australia from Dr. John Gargan, because he was doing a lot of management type things when we were putting that app together. So the app has gained a lot of followers. And so even though I'm no longer working for USDA or the Ag Research Service, I'm working for University of Nebraska. I get calls about the app in the middle of the summer, and I field those calls throughout the summer, because it really has provided some help to producers and people on the ground, as well as management back in the office, so they know how to deploy extra people or how to deploy resources that they need.
Yeah, that sounds like a wonderful resource, especially because it tells you not only when there is going to be some kind of heat stress event, but also helps offer solutions or potential ways to mitigate some of that heat stress. So we will be sure to link that app in the show notes for this episode.
Perfect.
Yeah, for sure. So Tami, with the increasing use of technology, do you think that technology could completely eradicate manual farming and possibly take over in the future?
So it depends on how you frame that question. Do I think we are going to eradicate animal caretakers? And I will be a staunch supporter of animal caretakers. We will never, ever raise animals without an animal caretaker. And I truly, truly believe that. But with that being said, are we going to change the job of the animal caretaker? Absolutely. So are we going to be asking people to come to the dairy at 4 a.m. or come feed pigs on Easter Sunday, or check chickens on Christmas Day and spend 12 hours in the barn on Christmas Day? No, we won't be asking those questions anymore. I think let's go 20 years in the future, or between 20 and 50 years in the future. I honestly believe we should have smaller farms. We'll have more diversification of farms. We'll be very techno savvy. So on your smartphone, you will be able to see a list of animals that need to be cared for. And that caring could be, these animals you need to go check because they could be sick, or it could be these animals need to be bred, or it could be these animals are ready to be marketed. And so I think technology is going to play a very key role, which changes changes the jobs we're going to be asking on farms. And right now we have a very tough situation where it's hard to get people to come onto farms and work with our animals. And a lot of our labor is the immigrant population, and those are hard jobs. So if we can ease those jobs and maybe reduce our reliance on foreign labor, I think we become more impervious to these massive disruptions such as COVID in the future. And anyway, so there you go. I know it's a long answer to a short question.
No, it's okay. It definitely gave me more insight to what the future will look like. And I'm excited.
Yeah,
to see.
I think have appreciated your description across a range of different species and some of the different opportunities and challenges that exist in the different sectors of animal agriculture. I wondered if there was anything else you would like to add at this point that you feel like should have been covered in this interview that wasn't.
Well, maybe not. The one thing I would like to point out is the changing of jobs means that we really, really need more students to engage in development of technologies, and not only development, but wanting to go back and help manage those systems for those producers. We can put all that technology in place, but if we don't have the labor force to go out and help maintain those systems, help calibrate those systems, make sure they're functioning, it's going to be a lot of wasted money, and we're going to be back to where we were. So we not only have to develop the systems, but we have to develop the labor force along with that, so we can make sure that the systems can be used properly.
Absolutely. Well, thank you so much for your time. I don't know, Asia, do you have anything else?
No,
you
I
wanna ask?
don't. No. Thank you, Tami.
Yes, it was a pleasure talking with you this afternoon. Thank you.
No problem. Thank you.
Thank you very much to Dr. Brown-Brandl for taking the time to join this episode of the FarmBits podcast. It is really excited to learn about the incorporation of technology in production and her contribution to education and innovation in animal agriculture.
One of my favorite parts of this episode was hearing all about all the digital tools available to producers across livestock species and how technology is improving animal well-being. Dr. Brown-Brandl's wealth of expertise was a great introduction to the digital animal ag tools. We look forward to discussing more with you in the future.
I hope you enjoyed this episode, and we look forward to sharing another digital ag story with you next week. Thank you for taking the time to join us today on the FarmBits podcast. If you enjoyed this episode, please subscribe to the podcast on Spotify, Apple Podcasts, YouTube, or wherever you listen to podcasts to be informed about the latest content each week.
We welcome your feedback, so if you have comments or questions for us, please reach out to us over email, on Twitter, or in the review section of your favorite podcast platform. Our contact information can be found in the show notes.
We would like to thank Nebraska Extension for their support of this podcast and their commitment to providing high-quality informational material to members of the agricultural community in Nebraska and beyond.
The opinions expressed by the hosts and guests on this podcast are solely their own and do not reflect the views of Nebraska Extension or the University of Nebraska, Lincoln.
We look forward to you joining us next week for another episode of FarmBits.